Welcome to this week's lecture video. We are going to kind of review what was done this past previous week and also preview what this new week is all about. You guys have been doing an awesome job of getting through the file system section, so I kind of want to just review that. In week 5 material, there were 3 items, modules 7, 8, and then the file system assignment. And it looks like you guys did pretty good. I do want to look at some of our resources with this assignment, and then I'll also kind of explore my own setup. I'll go to the root Linux manual book first and take a look at what they have for their file system setup. So first thing I'm going to do is take a look at the layout of the Unix directory. And the way this book mentions it is packages, which is more of the next week's material. We'll talk about packages. But what they're saying here is that not only is, almost everything a file, but almost everything is packaged together in such a way to kind of distribute the files. And there's different package managers and things like that. But here is what the Unix directory superstructure would look like. For the root directory on a Unix system typically will look like this. So we have bin, boot, dev, etc., etc., home, lib, lost and found, mount, proc, sbin, temp, user. And if you were to go into the user directory, you're going to see almost a duplication of all the ones in the subroot, and then some. You're going to see a little bit more. And now, if we were to go inside the user local directory, it could look something like this. Typically. And they're just listing out the contents in the long format. And what they're saying is the user x11 RS6 directory will look something similar. The key is that not only are their directories similar, but their subdirectories is similar as well, which they call it a directory superstructure or just a superstructure. What we have here is that the superstructure will always contain the bin and the lib subdirectories, but you will see some variations on some of the other. Here's a definition of some of the directories that you'll see in the root directory. The bin, which is the binary executables, this is where all the commands for the operating system is going to be stored inside the bin. So this is extremely sensitive. I would, like, if I had to scale it on a scale from secret to top secret, I would consider the bin directory as a top secret type of directory with respect to the computer. Or maybe we should say secret, and then SBIN is top secret, right? Because now SBIN is for the super user binary executable. These programs are for the system admin only. Only the root will have access to these executables, so you have to sign in as root to access this. If I try to access this as my regular user account that doesn't have those privileges, I won't be able to. The libraries, as it says, all other data needed by programs will go in here. Most packages have their own subdirectory under lib to store data files. And also the DLLs, which is the dynamically linked libraries, or the .so files are going to be there. Configuration files, and etc. Variable data, data files that are continually being recreated or updated. And whenever you have a web server, it will go inside the var, the variable data. So if you need to get into the web server and add files and edit a web page or website, you'd have to go inside your var and keep going inside until you get to your HTML folder. Documentation, manual, info, share. Okay, share is where we have the shared data, the architect, independent files, files that are independent of the hardware platform will go here. So files that would be independent, and that allows them to be shared across different machines, even though those machines may have a different kind of processor altogether. And we've seen shared files. Usually it's shared between users, where you can drop something in a shared file and another user can access those. Windows has this, although a lot of the settings by default are off. Source files include source, temp. So we have C header files. These are for development. Source files, these are sources to the kernel or locally built packages. And temp files, a convenient place for running program to create a file for temporary use. Yeah, not bad. I mean, it's good stuff. I have, well, I've downloaded a couple more books. Here's another book that is under the ebooks that everyone has access to. And if you go to chapter 6, so it's called The File System. Which of the following would you expect to find in a file system? Saying everything. All of the above. Alright, let's get into the organization of the file tree. This is something what we just saw in the other book. We just kind of want to see how it's laid out in this text as well. They kind of go over the etc directory, the var directory, and whatnot. It's good. It's all good stuff. So they're basically breaking down what each of the directories will stand for. And you guys did a good job of that. This is a typical setup. Now, if I pull up my Linux machine, and this one is the 18, the Windows subsystem. It's getting old now. It is getting old. Let me see if I can switch into root. Yep. Now, I'm still in the root home directory, but I want to get to the to the root directory, which I'm now in. And let's kind of see what is the structure here. So if I just do ls, here's my setup. Now if we do ls with a L, meaning the long format, it will list it out like so. And now we can see what's happening here. We have the bin, boot, dev, etc. Home, init, lib, lib64. It's usually not good practice to save things here. It gets messy. It's kind of like if you have a room, your own room, you don't want to put your clothes on the floor, right? There has to be some other place for that item. You could, but over time, it will present a problem, and sometimes it's going to be hard to locate things and have other programs access it, and so interesting. Okay, we have quite a lot here. Now, if I pull up my other machine, and this is the Ubuntu 8, but I'm going to pull up my 20.LTS, and this guy honestly has a kernel running inside of it. It has its own kernel. So this one's kind of souped up. I'm going to switch into root. And now we'll do ls in the long style. And this is what we're working with. Now, there were some things that I did download and save onto the subroot directory, like git and gem, things like that, but I'm not really using those things anymore. I always think I was working on something. Look at how it has, though. It actually has the bin, and even lists out another directory, the boot, dev, etc., home, init, lib, all the different libs, libraries there, media, mount, op, proc, root, run, sbin, snap, serve, sys, temp, user, var. Okay. I do have another machine, which is the Kali Linux machine, and I will actually, let's just switch into root. Hopefully this will work for me. It does. Change directory. Now Kali Linux is again another install of Kali. So I'm going to do ls long format. Does this remind you of something? The way it displayed it, the way Kali Linux just displayed it, reminds me of that Ubuntu 20.02 version, the one with the kernel built inside. My Kali Linux machine is set up the same way. This looks a lot cleaner. I actually haven't had much run on this machine at all, so this would make sense to keep this open in the way that it has been. Let's keep going through this book for a minute. We kept seeing proc, we kept seeing opt, we kept seeing mount, media, lib. We even saw the lost and found. Um, opt, optional software packages, proc, information about all running processes. Okay. SBin, we learned that is the super users binary folder. Stan, I don't think I saw Stan. In fact, Stan looks like it is related to just the H operating system, which would be HP and Unix machines. Whereas all will represent all, L will represent Linux only, and now it goes into a little bit more about what do we have inside here. We have regular files, directories, character device files, block device files, sockets, named pipes, first in, first out. Alright, this is where the processes are uh, being programmed within the operating system. First one you choose is going to be the first one out that gets executed. Usually that's the way they want it to happen, but it could be a waiting list. We can go in a little deep detail about that if any questions. But you can determine the type of existing file with the lsld command. And then what this tells you is it breaks down the type of existing file that it is. Um, and it's just here, and this is good to see this, that the first character of the ls output encodes the type. So this is a directory. If it was a regular file, it would have had this symbol, just a dash. So it can get a little detailed. Let's keep going through this. So now they're talking about the file attributes, the file permissions. This is actually a really good book. Sometimes you have to change the permission of a file. So yeah, I mean, it's a good resource there. This is the Unix and Linux System Admin Handbook, 4th edition. Great resource. So we do have a lot of resources when it comes to the file system. I think you guys did a really good job there. Also, there was the labs and the points will be brought over if I haven't done it already. So it is all due later this evening, but keep in mind you can work on this if you need more time. You can work on this assignment at a later date for the full credit. Now heading into week 6, we're going to be dealing with Module 9, and this is dealing with packages and archiving. And in Windows, oftentimes we could right-click on a directory and then choose to zip the file, which will actually animate the folder with a zip through it. And that basically means that you have bundled all those files together, and now you're able to either send it as one thing, which is in most cases it's used for, but also it can compress it, which will allow you to store, have more memory and things of this sort. So there are a lot of reasons why you'd want to do packaging, uh, packages and things like that. So in this assignment here, this covers the compression and archiving commands in the Linux system. And all of our books do a good job of explaining this. It is definitely important to get into. We can also look at some of those commands as well here. Let's see if I can, yeah. When it comes to archiving, and let's see here. Here they talk a little bit about using other archiving programs like tar, DD, ZFS backups. This is a big book. I mean, it's a massive resource. So hopefully you have a lot of memory on your device if you're going to use this and study from it, because it's huge. All right, and they're getting into other things that is beyond the scope of what we're doing in this course. But nevertheless, it's good to have a resource where you could kind of read this on your own as you may need. And the stuff doesn't change much either. That's the thing. And here, if I go to zip, for example, let's see, what would our choices be? Or maybe even archive. Let's see here. Yeah, I'm not finding that keyword there, not in this. All right, and what we could do is also take a look at the root Linux, and we'll go to, let's start from the table of contents. All right, so we have an idea of what this is covering, quite a lot. Let's see if we go into what about source and binary packages. Let's go there real quick. 237. So here they're just giving you good information about the standards. Complaints should also mean that the package can be installed with only the 3 following commands. And they have an example of how you could get comfortable in doing this. Interesting stuff. Here's another resource for us as well, and here's the CompTIA Linux Plus study guide. And most of you are probably looking on taking a few tests in the future on Linux. This will talk a little bit about the Linux directory structure, and then also we'll get into how to archive and compress and things like that as well. I'm sure it's a subtopic. Let's see if we can find that somewhere in this book. Alright, let's see here. Here we have managing packages and software. They even talk about how to automate certain tasks and schedule jobs. Like, this book is really good. So if we go to 453, they talk about yum, RPM. There's, you know, yep. So they're basically here, they're pointing out that the distribution relies on two different methods for managing the software lifecycle. The first method is the package manager, and this will install, update, and inventory and uninstall packages and whatnot. And this will govern the life cycle of the software life cycle of it. It's a lot easier now. It used to be a huge problem to update your machine, but now with package managers, you just hit a couple of commands and it's almost all automated. So here they're using the command in the CentOS, but we're not. You don't have to do that. If you are using your CentOS machine, though, make sure that you're going to be using the RPM command. Or yum. Sometimes they'll call it yum. And let's click on this assignment again here. And this is based on the Essential Linux book. Archiving files on the command line, and then also from this book here. How is an archive different from compression? What does the name of the tar command derive from? What are two advantages of tar? What are two options that allow tar to compress the archive it is making? Really straightforward stuff. Now they want you to actually carry out some tasks. So here, create several files in your user's home directory if it's currently empty. Create a tar file containing all of them. Screenshot this. So I mean, you could do a touch file 1, file 2, file 3, and also, and then you can tar them all, that single command. And where would you go for those commands? Well, if we actually pulled up the class book, let's make sure we have it. And you go to, I believe it's chapter 11. See if it'll jump down to page 145. Let's see. They talk about, let's make sure we can see this. because there's a chance that you might not have this command on your machine. You could archive it in any other uh, kind of archiving program that your machine has if it doesn't have it, or just download tar if you don't have it. So here they talk a little bit more about tar. So tar comes with options, then you do the file, and then there is an option to put the directory. Um, so here you're going to archive all the files that start with data. You're tarring that with a CVF. Okay, and then you're specifying where it's going to be the name and all the files. You can display it. So now you're learning how tar really works. And they talk a little bit about compressing files now. And with not only can you compress files, but you can decompress files using the gzip command. And they talk about it here. This is kind of a, say you have some kind of letter, you can gzip it, and it compresses it. You can decompress, list it, do whatever you need to do. There's another way to compress files called the bzip2 by Julian Seward. Is a compression program which is largely compatible with gzip. Uh, and so yeah, it's good. I mean, I don't think it'd be too terribly not too much trouble to get those things done and out of the way. It's the last reading assignment from that online book, which is right here, the Linux Essentials Manual. There's a link to it on the page, and also it's in our ebook, I believe. So the new material isn't going to be all that bad. There's also the online packages, and then there's the Module 9 as well. If you click on online packages and get to this link, you're going to be talking about the software distributions, the package repositories, tar and gzip. Okay, you're going to execute some commands with that. That's going to get you good at it. This could probably help you with your homework, the other assignment as well. Because look at that, that's what they're doing. You have two files, and you're archiving them. Here is where you unpack and extract, compress, and so on and so forth. And know the difference between compress and archive. And they also know the difference between the different packages, managers, and things like that. Where we have the Debian, Red Hat, and whatnot. Yum and app. Sometimes you put apt-get such and such or yum install, app install. It's two different. Just depends on the software that you're using. The operating system, the OS. And it's probably already on there, because when you download your OS, it's already pre-installed. Other than that, I think it's going to be a pretty smooth week for us. I think week 7 we're going to have another smooth week. I'm probably going to get rid of user manager, keep these 3. And then after that, we're going to be talking about a project. Okay, we'll have a day for this. And then we're going to do some more activities afterwards. But we'll be talking about the project real soon. Alright, so in the meantime, this complete weeks 5 and 6 material, and I will see you next week when we have our next meeting. That's going to do it for now.